everyone, my name is Guillermo López García and I work as a PhD student at the ICB lab of the Computer Science Department in the University of Málaga. First of all, I want to thank the organizers for giving me the fantastic opportunity to participate in such a beautiful event. So today, I will describe an example of how a state-of-the-art machine learning models can be successfully applied to the domain of biomedical text in Spanish. For the last 2 years, in our research group, we have focused on developing new strategies in order to adapt the most successful machine learning and deep learning models to the specificities of the biomedical domain. For example, we have successfully applied convolutional neural networks to gene expression data, and also, for example, to amino acid sequences. On the other hand, recently we have started to work in close collaboration with a group of physicians from the oncology department of the University Hospital in Málaga, with the main goal of extracting relevant clinical information from medical text in Spanish. In this context, we are particularly interested in developing automatic systems that perform clinical coding. For this reason, this year we decided to participate in the CanteMist competition, which was supported by the Plan TL. Specifically, we participated in the CanteMist coding subtask, which was basically a text classification task in which, for a set of oncology clinical cases in Spanish, the participating systems had to assign the oncology ICD codes represented in each text. So in the next slides, I'm going to describe how we approached this challenge and finally the results we obtained. We tackled the challenge using BERT, this popular and state-of-the-art transformer-based architecture. However, when applying BERT to the CanteMist coding task, we faced two main problems. Firstly, to the best of our knowledge, there is no publicly available BERT model which has been adapted to the Spanish clinical domain. In fact, all the available Spanish or multilingual BERT models have been pre-trained only on general domain corpora. The second problem we faced was that BERT can only process an input sequence of subtokens with a maximum size n, with n equals 512. However, most of the clinical documents present in the CanteMist corpus had a subtoken sequence size clearly above the maximum length supported by BERT. Now I'm going to describe our developed approach that solved these two previously mentioned problems. Firstly, we have to say that we used the multilingual BERT model, or MBERT, to initialize the weight of our own BERT model. Okay, so in order to adapt BERT to the Spanish clinical domain, we pre-trained the model on a private corpus of 31,000 oncology documents in Spanish, creating what we call OncoBERT. Then, instead of fine-tuning the model on a long text classification task, we split the long documents from the CanteMist corpus into small fragments of text. Using the annotations available for the CanteMist norm subtask, we managed to fine-tune BERT on a small fragment classification task. In this way, meeting the restriction imposed by the transformer architecture on the length of the input subtoken sequence. As you can see, one of the main features of our developed strategy is that it is a fully automatic end-to-end approach, without any manual feature engineering phase, nor any pre-processing step. The results obtained by OncoBERT on the CanteMist coding subtask were quite good. Actually, jointly with the VComTech team, we obtain the best performance according to the main evaluation metric of the task. Finally, given the good results obtained by Oncovert in Cantemist coding, also given the potential transferability of our automatic and end-to-end strategy, we are now working on adapting the fine-tuning process, which was recently described, to perform other clinically relevant text classification and name entity recognition tasks. For example, we are working on applying name entity recognition for TNM staging, or for example, text classification to predict the risk of hospital readmissions, or even the extraction of information from text of other health-related disciplines, such as physiotherapy. Finally, in the context of the current COVID-19 pandemic, we plan to participate in the Profner Challenge, also supported by the Plan TL. This competition proposes the identification of professions and occupations in health-related social media, particularly in the context of the COVID-19 epidemiology and mental health condition. So that's the end of the presentation. Thank you very much for your attention.